Hey guys, all right, we've been doing hypothesis testing about proportion and about mean from one sample from a population. So what we're going to do now is we're going to end up doing hypothesis testing about proportion, but this time we're going to do two samples. So we're going to kind of do a two proportion z-test instead of a one proportion z-test. Like usual, hopefully I'm going to pull up a PowerPoint and kind of talk you through it. And just like usual, I need you to take notes. Okay. All right. So this is hypothesis testing about two proportions. Okay. All right. A couple of factors that I want to kind of reiterate. They're not really going to be super important to you probably when you're working the problem, but they are to me so that you kind of understand some things that are important. I'm not going to make you check these three things. I'm going to kind of check them for you, but I want you to notice the samples have to be random samples. Okay, so we've talked about the fact that when you do sampling, if you have a convenient sample or your sampling technique's not good or use an appropriate method, you kind of invalidate your results. So you've just wasted money, time, and energy. So with this, they need to be random samples. Okay, the other thing is the samples need to be independently drawn. So what that means is when you draw one sample, that doesn't in any way impact what you might or might get when you draw your other sample. So they can't be like match pairs. Now, there are ways to do hypothesis testing on match pairs, but this is not it. Okay, so random samples, independent. The other thing that's true is for this to work, for what we're doing right now to be valid, each of your samples have to have at least 5 successes and 5 failures in each of your two samples. So I'll kind of alert you to what I'm talking about when I'll talk you through your examples in a second. Okay. Now, the book talks about 3 ways of doing this kind of testing: a P method, a critical value, in other words, the Z score method, or a confidence interval method. What we're going to be doing is the P method, because the book reminds you if you want to test a claim about two population proportions, you need to use the p-value method. Okay, in other words, you could use that or critical scores. And since our calculators do the p-value pretty quickly, we're going to go with the p-value method. Now, all that does is test the claim. So it's going to tell you whether or not basically your proportions are the same from the two samples. Now, if you want to estimate the difference in the proportion, then you have to go use that confidence interval method. So you can do that, and the book explains it, does a good job. We're not going to do that. We're just going to do confidence interval. We're not going to do confidence interval. We're just going to do the p-value method. All right. Now, most of this is exactly the same as what you've been doing before, so it shouldn't cause you any trouble. You're just going to go to a different test on your calculator. All right. But there is one slight thing that I need you to do now. Before I gave you the option, now I'm going to require it. Remember, the null hypothesis has to have equals in it. And you've been doing that the whole time. But for this, it needs to only have equals in it. So we're going to set it up the way we've been doing. But I'm going to have you go back and reevaluate. And so if your null hypothesis has less than or equals 2, you're going to change it to just equals, or has greater than or equal to, you're going to end up changing to just equals. So I want to kind of alert you that's really the only change, that and where you go on your calculator. Everything else is the same. Okay. Just like before, what I want you to do, there are a couple of slides that have a total of like 11 steps. I'm going to talk you through them. Then I want you to pause the video and copy the steps down. So then I want you to have all 11 steps next to you when we work the two examples. All right, so the first steps are the same. I want you to read the problem and take your pencil and underline in your book or on the test or whatever the claim. Then I want you to change that underlined claim to a mathematical sentence. All right, and then put claim next to it, remember, so you don't get lost on the flow chart. And now remember, when you're changing that claim to a mathematical sentence, use population symbols. So because we're going to be doing proportion, make sure you use P and not P hat. If in another class you were doing one about mean, then of course you would use mu, not X bar. All right, just like before, then I want you to write a second sentence that encompasses all the other possibilities. And then fourth step, just like before, I want you to label which one's the null hypothesis and which one's the alternative. And remember, we need both because we always test the null hypothesis. Remember, we don't always test the claim. Sometimes we test the claim and sometimes we don't. It simply depends on whether the claim is the null hypothesis. Okay, so the purpose of having a null is to know what to test. The purpose of having an alternative hypothesis is so you know what test to run. Okay, now remember, step 5 is the one that's a little different. I want you then to go back and look at what you've labeled as your null and change it to just equals. Now it may just be equals and you're good, but if it says less than equal to, I want you to change it to just equals. Or if it says greater than equal to, I want you to change it to just equals. Then go back and reread and find your significance level. They're going to just tell you what that is. Usually your most popular ones are 100th, 0.01, or decimal 0.5 500ths. All right. Then, just like before, you're going to write down what kind of test you're using, left-tailed, right-tailed, or two-tailed. Remember, if it's alternative hypothesis says less than, you're going to need, the calculator is going to need to use a left-tailed test. If the alternative hypothesis has greater than, you're going to write down right-tailed test. And if the alternative hypothesis has not equal to, I want you to write on your paper a two-tailed test. So pause the video, make sure these steps are in your notes. Right, now that you've got those 7 steps, just kind of keep going on steps 8 through 11. All right, 8 is a little different because remember, that's the calculator step. So just like before, you're going to be looking for a probability. So you're going to go back to stat like you did before. You're going to go to test like you did before. Now, here's the difference. When you were testing about a hypothesis before, you had one sample, so you did one prop z test, one proportion z test. Now you've got 2 samples. So you're going to choose 2 prop z test, 2 proportion, all right, z test. So do that on your calculator so you can see what I'm talking about. Notice it's asking you for an x1, n1, x2, n2. x1 and n1 come from your first sample. x2, n2 come from the second sample. And you get to decide kind of which one's which usually, but you're going to need to label it. And you'll see what I mean when we work the problems. Remember, n's the total the whole semester in your formulas. So this N1 is the total in your first sample. This N2 is the total in your second sample. And then X1 is the successes out of this first sample, and X2 is what you're looking for out of this second sample. Now the calculator wants you to highlight not equal to, less than, or greater than. So look at that alternative hypothesis and select your left, right, or two-tailed test. Make sure you calculate, make sure you highlight that calculate and hit enter, and then all that stuff comes on your screen like it's been doing. And you're looking for probability, so you're looking for P. So write that P value down from your calculator. And then just like before, you're going to take your P and you're going to compare it to alpha. Okay, if P is less than alpha, then you're going to reject the null. And just like before, if P is greater than or equal to, then you're going to fail to reject it. Okay, and then just like before, you're going to use that flow chart to write your answer. So I need you to pause the video. Okay, and I need you to copy down these 11 steps and then get ready to work those 2 examples with me. Okay. All right. All right, my machine's having a hard time. Let's see if it'll do it now. Okay. There, finally. Now it's happy. Okay. So let's work through the 2 examples now that you've got your steps beside you, I hope. First step, remember, says that you're going to read the problem and underline what you're looking for. Okay, so it says, suppose a study of Wendy's drive-through orders found that 264 of those, let me kind of move this so you can see it, 264 of those were accurate and 54 were not. All right, and then that's so basically Wendy's is getting some of the drive-through orders right and some of them not. Then we went to Rally's, all right, another fast food establishment. For Rally's, 329 orders were found to be accurate and 33 orders were not. They were not accurate. So it said use the 500 significance level to test the claim that Wendy's and Rally's have the same accuracy rates. Now, I look for test the claim that, just like I did before, and I underline what follows it. Okay, so that's why I underlined that. All right, then I go change that to a mathematical sentence. Now, because it says rates, that's how I know it's proportion. Okay, so remember what we said, the rates have the same accuracy rate. So of course that would imply that P1 equals P2. Okay, so that's why I have P1 equals P2. Now, if P1 doesn't equal P2, that will be my second sentence, remember? And now I've got to decide which one of those is my null and which one of those is my alternative. Okay, let's go back for a second. All right. So the one that's got equals, remember, that's my null. So remember, your book calls that H sub 0. All right. And then this one's my alternative, and your book's going to call that one H sub 1. Now, I just as soon put null and alternative, so you can do it any way you want to. Then it tells you to go find your alpha level. So I went and looked, and my significance level was 0.05. All right, so I wrote alpha's 0.05. And then remember, you look to see your alternative tells you what test to run. So my alternative has not equals. So that's how I knew to use a two-tailed test. All right, so in this one, are you testing your claim? Yes, in this one, I happen to be testing my claim because I always test the null hypothesis, and that just happens to be my claim. Okay, now you're going to need to put a note here so you know what P1 and P2 are. P1, I'm going to let be the proportion of accurate orders from Wendy's, and I'm going to let P2 be that proportion of accurate orders from Rally's. And I'm going to need to write that on my paper so that you can get partial credit from me and so you can not get lost yourself. So because it's two samples and I'm doing proportion hypothesis testing, remember I go to stat, go over to test, and I pick two prop Z tests, two sample proportion tests. Now, remember, I said P1 was Wendy's, so that's why this N is the total from Wendy's, and I'm doing accuracy rates, so these have to be my accurate orders, okay? Now, they didn't give me my total. They told me 264 were accurate and 54 were not accurate. I had to add those numbers to get this 318 total, okay? Then I went to my second sample that came from Rally's. You need to tell me that on your test. And my total was 362. I got that by adding the 33 to the 329, the good ones and the bad ones. And then I'm doing accuracy, so my accurate ones went there. All right, then I remember I have to tell it what test to run. So I go back and look, and I have not equals on my alternative. So I highlight not equal, and then I went and hit calculate. And remember, I'm looking for probability, so I'm choosing my P value. And I just rounded off and got about this. And then I'm going to compare P to alpha every time. Make sure you write down P first. Now I got a little lazy and just re-rounded it, to the 10,000th place. I'm looking for the first place, they're different. So they both have a 0 in the tenths column, but this has a 0 in the hundredths column, and that has a 5 in the hundredths column. And 0, of course, is less than 5. So if P is less than alpha, remember you reject the null. So I literally want you to write that on your paper. Okay. It's hard to do on this machine. All right, but you're going to write down reject the null. All right, and then you're going to go to that flow chart in your book. Man, that is just sad, isn't it? Let's see if I can do it this way, maybe a little bit easier. So I'm going to reject the null. So that flow chart says, does the original claim contain equality? So I go back and look. So that's why I labeled it claim. Yes, it does. So I went right on the yes on the flow chart. Then it said, did you reject the null? And I look, and yes, I did reject the null. So again, I'm following the yes on the flow chart. So I literally wrote down, I just copied down from the flow chart, there is sufficient evidence to warrant rejection of the claim that, and then I went back and put what I had underlined when I got to the ... part. So that part's exactly the same as you've been doing before. No different. Okay. So you're doing exactly the same thing that you've been doing before. All right, let's go look at a second example real quick. All right, look at this one. Suppose a study investigated the rates of fatalities among patients transported by helicopter versus the one transported by ground services like ambulance. Maybe you drove your dad to the hospital. It was found that 7,913 died among the 61,907 patients transported by helicopter, and 17,773 died among the 161,554 that were transported by ground services. So it says use the 0.01 significance level to test the claim that the rate of fatalities is higher among those transported by helicopter. All right, so I've read it. All right. So remember what your steps say. Oops. My steps tell me basically to go back and underline what in my claim. Okay. And this doesn't want to do that today. All right. So I'm going to underline the rate of fatalities is higher among those transported by helicopter. Okay. Now it's happy. All right. It's having a bad day too. All right. The rate of fatalities is higher among those transported by helicopter. So rates alerts me that it's proportion. So my rate is higher for one than the other. So that's why I have P1 is higher, in other words, greater than P2. And I wrote claim next to it. Now, which one did it say was higher? It was higher among the helicopter. So P1 is going to have to be the helicopter patients. And then P2 is going to end up being my ground services. So the helicopter rate's higher than the ground rate. Now, my next sentence, if it's not greater than, remember, then P must be less than or equal to P2. Okay. Then I label which one's my null and which one's my alternative. So remember, it's got equals in it. It's my null. So this one is my null. Okay. And this one's my alternative. I'll just put H sub 1. Okay. Now, remember what your next step says. It says kind of find your significance. It says go back and look, though, after you've labeled them. I need the null hypothesis to be just equal. So I'm going to go back and I'm going to get rid of this. And instead, I just change it to just P1 equals P2. So this is my null and this one is my alternative. Okay. So now this time, am I going to test my claim? No, you always test the null, and this time the null is not your claim. Okay, so I may ask you, are you testing your claim? And the answer is only yes if the null happens to be the claim. Okay, I look for my significance level. This time it's 0.01, so that's why I write that down. Remember, I look at my alternative. It's got greater than in it. So that's how I know I'm running a right tail test. Okay, now I go to my machine. I'm doing proportion for 2 samples. So I go to stat, I go over to test, and I pick 2 proportion z-test. Now remember, P1 are my helicopter patients. So there's my total, and it wanted fatalities. So that's why X1 are the fatalities, the people who didn't make it. Okay. My P2 was my ground services people. So there's my total for the ground services and my fatalities for the ground services. So I enter all of that. I go back to my alternative. It said greater than, so make sure you highlight the greater than choice on your test. All right. Go choose calculate. Now remember, you're looking for your p-value. Now, what do p's have to be between? Probabilities are between 0 and 1. So when you see this 2.7, this 2 7/10, don't write down 2.7. You know that's not right. When you go, it says E negative 27. So remember what that means. That really means that this decimal is 27 places to the left. So do you understand? I've got a decimal and 26 zeros and then 27. So it is a tiny, tiny number. All right. So I wasn't going to write down 26 zeros and then a 27, but you understand there'd be 26 zeros and then like a 27 here. And I'm comparing that to 0.01. Again, the first place they're different is that hundredths column. And 0 is less than 1. So again, I'm going to reject that null. Okay. Now it's kind of hard to type on this machine. So I'm just going to put reject here, but you're going to put reject the null. All right. And then go to that flow chart. So remember, the first thing on the flow chart says, does the claim contain equality? And this time the answer would be what? No. So this time, instead of going right on the flow chart, I'm going left. And then it said, did you reject the null? Well, yeah, I did. So now I choose the yes option. And I literally write down, there is sufficient evidence to support the claim that, and then the book says ... So when I get to the ... part, remember, you go back and write down what you underlined in the problem. Okay. So basically it's exactly what you've been doing before. All right. Not really any different. Okay. The only difference, of course, is you're not choosing 1 prop z test, you're choosing 2 prop z test. And so you're going to that on your machine. All right, so double check that that you know which one is N1, X1, which sample that's going with, and write it down for me. Where X2 and N2 are coming from, write that down for me so you don't get confused. Now, the fact that that second one, the fatality rate for helicopters was bigger than the ones for ground services isn't surprising. Now, the hypothesis test doesn't tell you why. It just tells you that they're different. But there are lots of reasons. I mean, it could be that it's more dangerous, but more than likely, the reason might be, you know, they don't send the helicopter if you just have a fender bender and you've like hurt your arm. Okay, the helicopter only, you know, gets dispatched if you're critical usually. So they're trying to get you there super fast. So it's not surprising that you probably have more fatalities from the people that are injured more severely. But the testing doesn't tell us that. Okay, it just tells us that they're different. Okay, so if you have any trouble, let me know.